get started?
Yeah, okay.
Is it just in the room? There's no webinars, there's nothing? So you guys get to see my slides today.
Yeah.
Okay, so this is following in line with the presentation that VR has done, some of our porting efforts that we've been doing for power architecture, specifically within Servergy, for a 32-bit platform. What I'm going to talk about today is more or less what we've been doing as far as full distro porting, taking the entire stack of software for a particular distribution and porting that over to 32-bit PowerPC. And a lot of the distributions already have 32-bit PowerPC support, Ubuntu, Debian, things like that. Some of the RPM-based distributions, they have lost their 32-bit PowerPC root over several iterations of their distribution, so that they don't really support our platform anymore, and we've had to manually go back and redo this whole entire base. Fortunately, we get some cases where we have a common base to work off of, so we don't have to do as much as we would do if we did an initial bootstrap of the system, which would be the case for a new architecture or a new processor. The starting point for most of these systems is when we decide, where we can start from, where do we have a common, root to be able to build off of, where there was 32-bit support, that we can bring the more modern version of the system into place. We have to have certain expectations of whether or not we're going to, have this whole entire stack build, or if we're just looking for a subset of it. There may be dependency chains that we can't follow just because, those stacks don't have support for 30-bit V8. The V8 library would be one case where we don't have any PowerPC support at all. A lot of the Java tool chains and things like that we can't fully support because we can't even get it. It would just require a whole lot of effort to port those things over. And so once we get an idea of what we want to be able to deliver, what we want to be able to support, and what we can reasonably expect to build, we can get started and have some idea of where we're going to have this go. At the beginning of this week, I've been using Cheroot environments mainly because of two things. One, it segregates it from the rest of the system. I don't have to have a fully built system in order to start doing this stuff. And the other thing is using something like Cheroot, we can do things where I have a Cheroot that's set up, and every time I kick off a build, it does a mirror of that with a backing cache into the file system, overlay file system, and that way every build always starts from pristine Cheroot, so we don't have to worry about cluttering and contaminating the environment. It's always going to start off the same way for every package, and it gives us an idea of the build dependencies that come with the source package, so we know it's going to pull it in, and if it doesn't pull it in off the automated stuff, we know there's either missing build dependencies, or we're going to have to manually put something into that root. That should be an essential part. It's an expectation of when the system builds that that package needs to be there. This is going to go a lot faster than expected because I don't have as many people ask questions. So there's two different ways we do this, and one way is where you have a common distribution such as CentOS or Red Hat. Those are two systems that are basically really close to each other, but when we were trying to do RHEL 5 and RHEL 6, we had to go back to CentOS 4 because that was the last time they had 32-bit support in the PowerPC system. And then we had to build RHEL on top of that, RHEL 5 on top of that. So that's where we get into cases where there's a whole lot of separation, and we get a lot of intertwining between old versions of libraries, new versions of libraries, old tool chains and new tool chains. The other case is much more simpler. The scenario where we did this was we had to do SLES, SUSE Enterprise Linux, and it's version 11. We can build it off of the OpenSUSE 11 because that's 32-bit already. It's a 32-bit PowerPC port. So that was a much easier scenario. we always have to start at a base that's older anyway. So there's no time that we build, say, Rail 5 if we have Rail 6 already built. We couldn't do that because then you have a problem where newer libraries, they have simple support for the older ABIs and things like that, but you can't build against this newer one and then all of a sudden jump this older library. So if you build on top of older libraries, it's easier to go to the new library because it'll still support things that we've already compiled against the older version of libraries. Stop me at any time if anybody has a question. So this is the similar distro-based bootstrapping that was like the CentOS 4.2 to Rail 5. Just like any other time you would do any sort of porting of a whole distribution, you have to go through the bootstrap stage. You manually build the core set of the tool chain, from the compiler to the base libraries, and there's some extension in this with some other libraries. Red Hat, they base a lot of stuff on SE Linux, and some other core libraries intertwine into the authentication and things. So those need to be bootstrapped as well, because otherwise you have a whole lot of dependency problems further down the line. When the builds start going, when you're talking about such a difference between these versions of libraries and versions of packages, you have to try to limit how much it's using of the older set to build the newer packages. Because down the line, you will get problems where, especially in Red Hat, it's not so much in SUSE because they do the smart thing. Red Hat has a library package name without the SO name creeped into it. So you'll have Ncurse's library, and it may be 5.1 and 5.2 or 5.3, but it's the same package name, and you can't install the similar ones because they'll overlap each other, and you'll break your dependencies, you'll break things during the build, and you don't have any idea where things are built and what they're built against. When you run through the first, I have an automated setup right now. I'm not using any of the tools that are generally out there because they were really lacking in some of the things we needed to do. But what it does is the build script, it goes through and creates a Shrew environment. It logs into it, sets up some variables for RPM and a few other things, installs a source package, and then installs all the dependencies through, for Red Hat, it would be through Yum. And then it starts the build with RPM build. Doing this automated through the first time, there's going to be a lot of cases in that first run where a lot of things are just going to fail. And you're not going to have any other way to deal with this, but that's just what's going to happen because a lot of the build dependencies will be on versions that haven't built yet.
So does Yum build missing dependencies, or do you have to build it?
You have to go through and let some of it pass, and you get it to a certain level, and then you run through all of the failures and let them build and see if any of that stuff fixed it. But the automated scripts with the Shrew environment, because it does pristine, it updates the environment and then uses the newer packages from the builds. So anything that gets built is being used in the next build. So the reason I had on here is about a stage 2 is just like when you're doing a compiler and you're doing the first stage of building that compiler, and it gets to a second stage where it rebuilds itself with itself. Even after you get a pretty large amount of this done, it's so likely that you'll have all of these interconnecting dependencies between libraries of the older version, new packages, or depending on older packages, and vice versa. And there's so much likelihood of that it's good to just take this new set of stuff and then just hit up every single build to start over again, so that you're trying to alleviate a lot of those interdependencies between the old base and the new base. On the other side, where you've got a pretty close match between OpenSUSE and SLES, or SLES is mostly a subset of packages that are recompiled for the enterprise lib. OpenSUSE has everything where SLES doesn't have all the packages. It uses stuff off of OpenSUSE. But it means that SLES is always going to have, the version numbers are always going to be newer than what was in OpenSUSE. So we know that when we start out with OpenSUSE, when SLES builds, it's going to start using those newer packages for the rest of the builds. And So we go through the same process of doing GCC bin utils and glibc just because you want to bootstrap with the tool chain that you're going to be building. So we make sure that we don't want to build with the old stuff and then find out the new compiler doesn't work. So on this one, when you do the automated build, you give it full access to everything, just because it's in this case it's very unlikely that you're going to have those kind of backward dependencies that are clogging up the installs and things like that. Generally, a lot of stuff builds because it's not waiting on something that hasn't built yet for the most part. Usually you can use everything out of the old base to build with the new system. And for that reason, there's not really a need for a stage 2 at this point. So this is a much easier and much more clean scenario to go through. What happens, especially in the CentOS versus RHEL scenario, when we start getting these build failures, because the system that's doing the builds doesn't have any knowledge of the dependency chains, it's just trying to build. If it fails to build, it doesn't care why, it just fails. So there's a lot of cases where I've had to go through and say the known libraries. A lot of stuff depends on it. There's maybe 80 to 120 failures because it's waiting for that library to build. Well, I go to see why that hasn't built, and it's depending on another package, and that package hasn't built because it needs something else that hasn't built, and so on and so on. And you might get down 8 packages away to try to get this dependency chain fixed, and you're manually popping off builds, and then you get back up, and all of a sudden you come back down again, and you're just creating these long trees of dependency chains. And this is a real big hassle. And the reason is because when these distributions create this, they're not the ones who are going to have to go through and back forth and stuff. They don't care that there's this huge spaghetti of dependency chains that get involved in everything, because they're not concerned about doing this bootstrap base. So it would be helpful. I haven't gone through and done it yet, but if I could have the time to create some tools to look through all the build dependencies versus binary dependencies, versus the APIs and all this stuff, especially with libraries, it would probably be a good way to help having to manually go through and do this whole process. All right, so that after the 2 stages on both of these, you get to a point where you just want to do the final build stage, which is just doing a rebuild of everything from scratch again, just to self-host the whole environment. So you know it's been built with itself, you know it's going to depend on nothing but itself. There's no chance of something looking it up from, coming from the old base and that sort of thing. This is when you start segregating it away from the original packages. They're not in the yum or the repository or whatever. It has no access to those. So if you have a build failure in this stage and it's because there's something missing, I mean, it's all inside of this. You don't want to pick anything up to help this build setup. And then from there, you can do checks on the system. It's easy to do something with the repositories for Yum and Zipper and apt-get to see if every package has a dependency satisfaction so that it can be installed no matter what. And then this is where we come to how to fix things up. And through all this whole process of doing this thing, and I think I've done probably 3, maybe 4 of these entire distro builds and using the same process. In Ubuntu and Debian, and I don't know who's familiar with it or not, but they have a build system that's called sbuild. And it's smart enough to know it's an automated daemon type thing that will wait for packages to be built, and it's aware of dependencies. So if there is a package that it can't build without and it's not available, it will sit and wait. Now, if that package comes in all of a sudden and gets built and successfully done, it'll trigger that last build. So it's smart enough to know when this whole, the dependency chains, it can satisfy itself, and it can pretty much automatically do what I've had to do manually. I haven't found anything like that for the RPM-based distros. It would be pretty nice to have, but I think they lack a lot of significant policy that Debian inherently has in its packaging system to be able to, with a lot of confidence, say what it needs and what the failures are for. packages that I did have had a flag that you could pass to RPM build that would tell it, I just want to do this as a bootstrap. GCC was a good case because if you don't set it into a bootstrap mode, it's going to try to build GCC, Java, GCJ. And the problem with that is it tries to build a Mozilla plugin, so you have to have Zool Runner and all this other stuff installed in there that is going to require X11, which is going to require Mesa, which is just, you don't need all that to build a stupid compiler. So it has a flag you can pass to it that does bootstrap, and a couple of the packages do the same thing, but none of them are consistently done the same way. So it's not like you can put a flag in the whole build system and expect everything to bootstrap so you get the minimum amount of dependencies and things like that. If there was a better policy for a bootstrapping phase for systems, even a core set of packages that you know this is the ones you should build first and get this out of the way, and then you can just flip the switch and turn everything on. And like I mentioned before, having some sort of analysis tools to go through and look at all of these, not only the binary dependency chains, but the source dependency chains, the build requirements and things like that, could go along with at least pinpointing problems, circular loops, which was a huge deal. Actually, I probably ran into about 15 circular loops where you get down the dependency chain and this thing required the thing that you're initially trying to build. And that was the biggest hassle, because then you have to force builds without certain dependencies. You have to force features to be disabled and that sort of thing. And then you have to go through and rebuild everything back again with those features enabled. And it's something that probably could be picked up and at least fixed, or at least use a bootstrap sort of thing to get around it, at least in certain phases of the build.